Hi guys, welcome to Piece of Code and welcome to this video. In this video we're going to start with chapter 4, and if you remember in chapter number 3 we covered a lot of Java core APIs like string builder, strings, arrays, some functions about strings and string builder, date and time API and such. So from chapter number 4 we're going to dig deeper into this object oriented concepts one by one, and in chapter number 5 it will be completely based on class concepts, right? We're going to dig deeper into this particular class concept, but in chapter number 4 we're going to cover methods and encapsulation, right? And the subtopics in this chapter number 4 is basically working with methods and encapsulation, and we're going to also work with selected classes from the Java API. We can also learn about lambda functions and stuff, right? So it's a very interesting chapter, so I hope you will like it. So the agenda for today's session is basically we're going to discuss about methods today, and we're going to see what are methods in Java, what are optional specifiers that we can specify with the methods in Java, what is a return type of a method, what is method name, what are the parameters, and what are this exception list, right? We can have that optional exception list, and then we're going to see what is this method body and what are varargs. So one by one let us discuss methods in Java in depth, right? So let's talk about this method structure in Java. So basically when you create a method, this is how the method is actually structured. So it consists of a access modifier, which is probably public, private, protected, and the default one, and then we have this is the optional specifier, which is final. This final keyword says that if the method is final or not. Basically if you mark a method as final, then it means that you cannot override that method in the child classes, and we're gonna discuss this in detail in our classes and objects chapter, so don't worry about it, but it is optional, so just have to know about it. This is the return type, which specifies what the method is gonna return, right? If it is going to return something or not. If you're gonna specify a void over here, then it just means that the method is not going to return anything. Then there is a method name. It's also mandatory, you have to give the name of the method, and in the pair of this parenthesis that you see, you have to specify the parameters for the method. Parameters are nothing but the local variables of the method that you're going to use, right? For example, you want to add two numbers, so you call that function add with two numbers 10, 5. So these two numbers that you see over here, it should be accepted as parameters into this method, right? Like int a, int b, otherwise you're not going to be able to use it, right? So this is how it works. Then there is exception. So a method can optionally throw an exception, right? And we're going to discuss about exceptions later on, but an exception is just an unexpected error, you can say, that occurs in your code. Like for example, you can, if you have worked with arrays, and if you access an index which is not present in the array, right? It means that if the size of an array is 3 and you are accessing an index number 3 over here which is not present in this array, then you get a array index out of bounds exception, right? So that is one of the exceptions, and you can specify that okay, my method is throwing that kind of exception, so that the caller may able to handle that exception, but that's a different case. But it is also optional, you don't have to write it every time, so that's the thing. Then comes this pair of curly braces, and inside this pair of curly braces you specify the method body, whatever the content of the method, what instructions you gave, you want to write in the method, so that the method when it executes those instructions will get executed. It's just pieces of code, that's it. Like in the add method you just return a plus b, so that is the body of the method, right? So this is the structure of a method in Java, guys. The only important or the mandatory things over here is this return type, method name, and this parenthesis is required, but you don't have to always pass the parameters. So parameters are optional, but if you need it you have to pass it, and this curly braces, and obviously the method body. Other than that, the access modifier is, it is not mandatory to specify an access modifier. If you do not specify an access modifier, it becomes default access modifier, right? And we're going to discuss what public, private, protected, default access modifiers are. And you don't have to specify this final optional keyword. That is also up to you. If you want to make your method final, then specify it, otherwise it's fine. Only this parenthesis and the pair of curly braces are mandatory. Other than that, other things are not mandatory. I hope that makes sense. So let us move on to parts of a method declaration. I have already told you, right? Access modifiers are not required. Optional specify final is not required. It means it's not mandatory. You can use it if you want. Return type is mandatory, yes. Method name is mandatory. Parameter list, yes, but can be empty parentheses. I've told you, right? If you need, parameters, then you have to pass it in the parentheses. Otherwise, it is not required. Optional exception list. This is also not mandatory, but if your method throws an exception and you want to inform the caller of the method that yes, my method throws an exception, then you have to specify this. And method body, you have to provide this pair of curly braces, but you can have an empty method unless the method returns something, right? Otherwise, if the method returns something, then you have to use the return keyword and return something from the method. Otherwise, there will be a compilation issue. I hope this part is clear, guys, because it's very important, and in the exam they actually try to trick you by letting some of the parts of the method here and there, and if you get confused and if you are doubtful about which is mandatory and which is not, then you're going to get confused, right? So let us move on and talk about access modifiers, guys. So talking about access modifiers in Java provides you with 4 types of access modifiers. One is public, one is private, one is protected, and one is default. You can also specify it as access specifiers, so that is fine. Whatever you want to call it, you can call it. So how does these access modifiers or specifiers work? You can mark access modifiers or specifiers to an element, like for example a variable, a method, or a class in Java. You can say public class ABC. You can also say public int x. You can also mark a method with this public specifier like public void add. So you can use access specifiers whenever you want with any element in your class. But this is specific to methods, so let us discuss about in the terms of a method. If I mark a method add with the public access specifier, then what happens is that this add method is actually accessible everywhere, including the same class where it is defined, including any other class. Wherever you want to call it, you can call it. Just create the object of the class and access the method add, right? It is accessible everywhere. So I'm going to just say everywhere. If I mark this add method as private, then it is only accessible in the class it is defined. In this case, it is defined in the class ABC, right? So it is only accessible in the class ABC, right? I hope that makes sense. So actually private access specifier is just the opposite of public access specifier. You can just remember it like that. Talking about the protected access specifier, if I mark this add method as protected access specifier, like protected add, something like that, protected void add, then what happens is that it is accessible in the same class ABC, all classes in the same package, and all of its child classes. So what does it mean? If I mark this add, this add method as protected, then it is accessible in the same class where it is defined, which is ABC, all the classes which is present in the same package. If this class ABC is present in package P1, then whatever classes are there in package P1 will be able to access this add method. Apart from that, any other child classes, whether it may be present in the same package, whether it may be present in a different package, if there is a child class of class ABC, irrespective of it present in the same package or not, that class will be able to access this add method. I hope that makes sense. Now talking about the default access specifier, it is kind of same as protected access specifier. The only difference is that it cannot be accessed from a different package. Even if there is a child class of class ABC present in a different package, that class cannot access add, which is possible in the case of protected. So default specifier, you can remember it as the same property as protected access specifier. Only difference is that it cannot be accessed in a different package even though there is a child class present in the different package. I hope that makes sense now. Right? Now let us talk about, some examples where you can get confused. Right? Let us go into this particular Eclipse, and let us just create a new package over here. Just let me create a new package over here and let us start working with it. So I'm going to say new package, and I'm going to say like methods, right? And let us create a class over here, and let us create the class as, for example, ABC, right? And click on finish over here. Okay, so let us see some examples where there is a valid method declaration and some examples where it is an invalid method declaration. And up to this point, you know how methods are declared, right? What are the mandatory components and what are the non-mandatory components. All right, if I write something like public void walk1, then this is a valid method declaration, because see, we are specifying the access specifier as public, which is fine, and we are specifying the mandatory component, which is return type, which is void, and this is the method name, which is mandatory, and we are specifying. And we can keep an empty method like this, so it's fine. There is no issue with this. Let us see another example, and let's say default void walk2, and let's see. In this case, there is a compilation issue, because it says it doesn't compile. Why? Because see, even though default is an access specifier, you don't have to specify or mark a method as default like this. If you do not specify anything, then automatically it is marked as default. But in this case, it is throwing an compilation issue because you do not have to mark something as default to make it default. Alright, so this is one of the cases where it is wrong. So let us see this particular example. I'm going to say void public walk3, and I'm going to say like this. Now in this particular case, you can see that all the required components of a method is there, but the problem is it is not in the right order. Always remember that return type, method name, this should be present always, and the list of parameters like this. Apart from this particular required components that you see, the order of this required components that you see over here, other things may be here and there. You don't care about that. Only the return type and the method name should be in the right order. The return type should always come before the method name. And in this case, if you see that we are specifying the access specifier after this return type, which is not correct, right? The method name should be after void. Always remember that. I hope that makes sense. Let me just comment this out so that we do not face errors. So talking about optional specifiers, and we have already talked about some of the optional specifiers, but there are also a number of other optional specifiers, and most of them are not in the OCA exam, but some of optional specifiers which go like this. They are static. If you want to create a static method, then that is fine. You have to use the static keyword. And another one is abstract. So the abstract keyword is to make an abstract method. So an abstract method is a type of method which does not have a method body, right? I haven't put this in the method components part because these are not present in the exam, and also you have to know about certain other concepts to be clear on these particular things. But I'm going to just say it in case you are asked in the exam, like if this is a component of a method or not. So static and abstract, and we cover abstract in chapter number 5, so don't worry about it. And also we are going to cover static in this chapter, so that's why I'm just give you a heads up. And also final, and you already know what final is, right? I've discussed this in the thing. And there is another thing that is known as synchronized, and synchronized is basically used to prevent deadlocks, right? If you're gonna learn about multi-threading, you would understand what a deadlock is. So using the synchronized keyword, what you do is you make the method thread safe, so that at any point of time only one thread will be able to access that resource. In this case, that is the method. So you don't have to worry about this thing. It's a advanced concept and we're not gonna cover this right now, but just keep in mind there is also, you can also use the synchronized keyword with a method, right? And there is also another keyword known as native, and it is not on the OCA and even on the OCP exam, so we just ignore it. But just for a context, it is used when interacting with code written in another language such as C or C++. So right, it's used to convert to native code. And there is another one that is known as strict FP. This is not even in the OCA or the OCP exam. It is used for making floating point calculations portable. Alright, again, just focus on the syntax for now and let us see some more examples if they compile or not. But always remember that the return type should always come before the method name. If there is something wrong with this particular thing, then obviously the method will not compile. Other components like these things, these keywords can be jumbled up like anywhere you want. It's not that much mandatory. Let's see some other examples, right? Alright, let's see this example, public final. Alright, public final, for example, walk 2. So if you see in this case, what is happening over here? We have missed that particular return type, right? So if we add that void over here, then this compiles fine. And if you see, you can write final before public before final, it doesn't matter. Only the return type before the method name should be there, should be in the right order. Let's see this another example. Public static, this is a static method, public static final void walk 3. This is also fine, because you see return type, method name at the right place. Other than that, we have one thing that is public, one thing that is static, one thing that is final. It's completely fine, guys. If I write it like this, final public static void walk 4, then also you see it's completely fine, because I've told you, right, the components which are not mandatory components, you can jumble it up as much as you want. The only thing that you need to take care of is this return type and method name, right? So if I write something like public void final walk 6, then you can see that it doesn't compile, because obviously this order, return type and method name, is in the different order, and it's not gonna work in this case. So keep that in mind, guys, and you will ace every question regarding methods in the exam. Let us talk about the return type. Now the thing is, the return type might be an actual Java type such as a string or an int, and if there is no return type, the void keyword is used. That much thing should be clear to you guys. So while checking return types, right, you also have to look inside the method body, because methods with a return type other than void are required to have a return statement inside the method body. If a method is marked with a return type and it doesn't have a return keyword, then you know it's going to throw a compilation issue. So let's see an example. If I say int, I don't know, add, and I'm gonna say int a comma int b, and if I say return, if I don't say anything, right, then you can see there is a compilation issue over here which says there must be a return, a result of type int. It is not returning anything. And if I add something, for example return 0 over here, then you can see the compilation issue is gone. Let's see this example. I say void add, and I say int a and int b. Let's make it 1, otherwise there will be an issue regarding polymorphism. Don't worry about that, we're going to discuss that later on. And you can see if I just ignore that return statement, then it is fine. but in the exam they may trick you. How they can trick you is something like this. If they add a return like this, you can see even though the method is not returning anything, it means it's void, I am using the return statement over here, and this is actually not mandatory. So, but it is not mandatory doesn't mean that you cannot use it. You can use it, but it is not mandatory. And the exam question will try to trick you in this case. You will think that it's a void, so why do we need a return statement over here? But the actual fact is that it can have a return statement, but the fact is that it is not returning anything. We are just using the return statement. As you can see over here, we are returning 0 from it, which is an integer. But in this case, we are using the return statement, but we are not returning anything from this method. So it's actually fine, right? I hope that makes sense. So if you do this thing, let us see some conditional returns, right? Because you may get confused in conditional returns. Let's see boolean check, right? And I accept int a over here. And if I say if a equals to 5, then return true. Now I am returning something from this method, but why am I getting this particular error in this statement? The problem here is that it's gonna return true only if the value of a is equals to 5. If the value of a is not equals to 5, there is actually not an explicit or an implicit return statement over here. So if the value of a is not 5, then we should return false, right? Accordingly to common sense, we're going to return a false value. So we're going to have another return statement in this case which says false, return false, and you can see now the error is gone, because if the value of a is not equals to 5, then by default it will return a false value. So always remember that if a method has a return type, then at all cases, at all points, it has to return something. And always be aware of these conditional returns, because you may get confused that okay, there is a return statement in the method, so I don't have to check for anything, right? But always remember there should be an implicit return statement that if none of the conditions match, that return must execute. Alright, I hope that makes sense over here. Right now, alright, now there is another thing that I want to discuss. If I say public string return, for example, public string name, and if I return, it's not returning anything. If I return a empty string, then it's fine. And if I return a null over here, you see, then it is also fine. The thing is that you can return the default values of your certain data types also, right? Because string is a class over here, right? So a class can return a null value. A class can hold, an object can hold a null value, right? So a string, if it is returning a null value over here other than a string value, then don't think that it will be a compilation issue over here. It will definitely work, but the thing is it will return a null value. So I hope that makes sense, because it's really difficult to examine and choose the correct answer, but as you practice more and more, you will get used to it. Alright, I hope that makes sense. Let's move on to the next topic. And okay, let us actually do some more examples and then we're going to move to the next topic. So let us see this particular thing. Let's say I'm gonna take another example. I'm gonna say int long value, and I'm gonna just say return 9L. Now the problem here, it doesn't compile, because you see we are explicitly returning a long value, but the return type is int. If we just return 9 over here, then it is fine. But if we return a 9L, then this should match the exact data type that it is returning. It should be a long type. But if I do this thing, if I do long int value, and if I try to return 10 from it, then it is fine, because see, this is a bigger data type than int. So if you try to assign an integer to a long, and if you remember our variables chapter, then it is completely fine, right? So always remember that this kind of stuff also happens. If you see something like int something something and it is returning a long value, then it will obviously be a compilation issue, because integer cannot hold a data which is greater than its integer, right? Because long is greater than integer. I hope that makes sense. So yeah, that's about it. And also remember that method can also return a local value, I mean a local variable, I mean. So it just means that if I say something like int local value, I'm just naming it so that it makes some sense. If I say int temp equals to 15 and I say return temp, then it's completely fine, because see, it's just holding the value of 15 and we are returning that value. So it makes sense, it can also return a local variable. Alright, let's move on to the next topic, which is method names. Now talking about method names, guys, method names are nothing but what are the valid method names that you can give to a method. And method name follows the same rules as we practiced with variables names in chapter number 1, if you remember. So to review, so basically if you remember, an identifier can have what? It can contain only letters, numbers, dollar or underscore. Apart from that, if we do something like messier, then it will not work, it will throw a compiler error. And the same thing that you cannot start with a number. Obviously if you start with a number, then it's an invalid identifier. So you have to identifier, like in some questions in the exam they may give invalid identifier names to a method, so you need to identify those. For example, let us see these examples, right? If I say void walk1, then if you see, that is a valid one, because it just falls under this rule. If I say void I don't know, to walk, this is invalid because it cannot start with a number. If I say I don't know, void something like this, this is also invalid because we cannot use keywords as identifiers. Alright, let's see this example. If I say void walk underscore dollar, it's a completely valid identifier because we can use underscore and dollars in our particular method names. If I say void I don't know, void and I do not give a method name, in this case it's also invalid because a method name is absolutely necessary and it's a mandatory component of a method. I hope that makes sense. So you should keep these things in mind, because I wanted to tell you that even though you know a lot of things about methods and classes, I don't know, in Java, but sometimes they will try to trick you in very elementary things like method names or identifiers. So keep an eye on that. Alright, let us talk about parameter list, right? So this parameter list that you see, what can be valid parameter list and what can be invalid parameter list. And as you can see from this example, you can leave this empty, but this pair of parentheses is always necessary, you have to give it. If I do not give this pair of parentheses, then it's a invalid method, it will throw a compilation issue. So if I do something like this, I don't know, int method 1, and if I say int a semicolon int b, you see this is an invalid thing because you can only use commas which separate your parameters. If you use semicolons like this, then it is not going to work. And similarly, I cannot leave these parameter things empty, because if I leave it empty, then there will be empty means if I remove this parenthesis altogether, then this is also an invalid method. You can say this is invalid method and it is throwing compilation issue, so it's also not valid. Alright, I hope this parameter list is also clear to you guys. Now let us talk about that exception list, right? I mean that throws keyword that we use, right? In Java, right, code can indicate that something went wrong. It means it throws an exception. And don't worry, we're gonna cover these exceptions, this throws keyword, try, catch, everything in chapter number 6, which is exceptions. For now, you just need to know that it is optional and where in the method signature it goes if it's present, right? You have to know that, okay, this is the place where the exceptions go, right? You don't have to worry about how the exceptions are handled and stuff, but for now just understand that, yeah, this is the place where I write those exceptions, that my method is throwing the exceptions. So just remember that always after the parenthesis, like the parameter list, the throws keywords go. It goes like this. If I say void method 1 and I say throws array index out of bound exception. So you cannot write this throws over here before the method declaration, or I don't know, in between void or method 1. It is always present after the list of parameters, after this parenthesis. If your method throws an exception, it will always be present over here. Don't worry about the rules regarding these exceptions and everything, right? And don't worry about anything else. Now a method may also throw multiple exceptions, because multiple problems may happen in your code, obviously. So a method can also throw multiple exceptions. If I say method 2 and it throws a array index out of bounds exception, and for example it is also throwing an illegal, I don't know, argument exception. So you can see that yes, a method can throw multiple exceptions over here. If you see some code like this, don't get confused that a method can only throw one exception. It can also throw multiple exceptions. And always be aware of this comma. If sometimes it says a semicolon over here, then you can see it's a error. Always things are separated in Java using commas. I hope that makes sense. Right. So don't worry about all the techniques regarding exceptions. We're going to cover this in detail in chapter number 6. Alright, now always remember, talking about the method body, right guys, as I've already told you that you cannot leave a method without a pair of these curly braces. Even though your method is empty, it should have at least this pair of curly braces. If I leave this method empty like this, then there will be an error that this method doesn't have a body. So always remember, your method will have a body, which means that this pair of curly braces, and if your method returns something, then a return statement is mandatory in the body of your method. I hope that makes sense. Now that are all about the basics of methods and how you should identify correct methods and how to write correct methods. Now the last thing that I want to discuss, actually we have already discussed this previously in some other chapter, I remember. This is about varargs, guys, and I think yes, we discussed this in our arrays chapter, but let us talk about varargs for a minute. Now the vararg parameter is basically it's kind of an array. You can access it as an array, but it's a little different than an array. So vararg parameter must be the last element in a method's parameter list. Always remember that. This implies you are only allowed to have one vararg parameter per method. And I have already discussed this in detail in the arrays chapter, so you can go there and refer to it. I'm just gonna go over the rules once so that you do not forget about it. So if I say something like this, I don't know, void walk7, and if I say int, and this is how you define a vararg. You go the data type and you say 3 dots, and then you say, for example, nums, and inside the method or something like that, you can say walk7 of 0. You can, sorry, not walk7, this is nums of 0. So it's exactly accessing the element in a vararg is exactly the same as you access it in a array. And when you call this walk7, for example, I call this walk7 from method 1, right? If I call this walk7, how do you pass the elements? You can pass it like 1 2 3 4 5. So this particular set of elements will go as an array inside this varargs argument, and you can just access it like an array over like this. So there can be only one vararg argument as a parameter in your method. If you want to have multiple arguments, for example, let us take another example. I would say walk8 over here, and if you want to have like other arguments, for example a string s, it should be before the vararg argument. It cannot be after the vararg argument. Your vararg argument must be the last parameter in your parameter list. If I try to do this thing, if I try to do walk9 maybe, and if I try to pass two types of varargs, one is a string vararg and one is a nums vararg, you can see this is throwing an error. Even if I try to pass in two vararg, integer type vararg, it is also throwing an error over here, if you see, because we can only have one vararg argument. Okay, this is fine. And you cannot pass the vararg before another element. For example, if I try to do like walk10, and if I try to do this thing, like before I pass the string s, I try to pass in the vararg and then I pass in string s over here, then it's also not possible because the vararg must be the last element in your parameter list. So yeah, that's how you are gonna deal with varargs, and I hope that is completely fine. And this is how you can call a vararg like this. If you see, you just call the method like walk7 and you pass in the vararg arguments like this. And for example, this method that you see, string s, first of all we pass a variable, normal variable, and then we pass the varargs like this, right? You can call this method like this. You can just say walk8 and you can just say Akash as the first argument, which is the string argument, which is fine, and then you can pass your varargs like 1, 2 or 3 or something like that, right? You can also pass one element as a vararg there, so in the array there will be only one element. And even if I don't pass anything as the vararg, it's also fine. It's not mandatory that you should pass something into the vararg. The vararg can accept 0 or 1 elements. Let me just write it down over here. A vararg can accept 0 or more elements, right? So even if I don't pass in the vararg, which is nums, then also it is fine. But the problem here will be, as there are no elements in the particular vararg, if I do this thing, then there will be a exception. Why? Because there are no elements and I'm trying to access the first element over here. So you should also keep an eye on those things, right? I hope that makes sense. So that's all about it for this lecture, guys. We learned a lot about this methods, and you understood how to create methods. And from the next lecture we're gonna cover some other topics in this particular chapter, like we're gonna cover a little bit in depth about access modifiers and a lot of other things like overloading methods and stuff like that, encapsulation, lambdas. We're gonna cover this in this particular chapter. Yeah, so that's it from my side for this lecture, guys. I hope you like the lecture. Have a nice day and bye bye.